Okay, we're back. Remember last YouTube, I talked a little bit about TMAOA. This comes from the fish. And we said it sort of reduced and converted to the trimethylamine. And that's what the smell is, right? We add vinegar. Now, vinegar is acetic acid, basically, 6%. And then become the salt. Now, the salt doesn't have any smell. So the question I ask myself is, how much vinegar do we really need? So if I look at so what I need, few things here. And we're going to emphasize the moles. So that's really the key learning from this experiment. And presentation is moles, when you need to know something about moles. Now the fish we use was 2 pounds. So it was a 2-pound fish. But in chemistry, we use grams and kilograms and units that are not British or American units. We have to convert the 2 pounds to grams. We know that 1 pound of anything, basically as a weight, is 450 grams. So if I use the ratio, and the ratio is set that the pound and the pound are cancelled. So I really, only thing I need to do is to multiply 2 by 453 to get how much fish we use in the recipe. If I do this in an Excel sheet, I had 906 grams of the fish we use. So the unit now is gram. Now I assume the fish has 6%. 6%. No, I'm sorry. 0.06% TMOA in it. 0.06. Now if I take 906 multiply, I cannot really multiply by 0.06. Remember, 0.06 is a percent. So to use it as part of the calculation, I always put 0.06 divided by 100. Remember, percent is a unitless identity. So if I have 0.06 here, so this is gram of the fish. So this is gram of TMOA. So this is gram of the fish. So these two cancel. And if I did this right, my TMOA is 0.54 grams. Okay, so I have a gram, roughly, of the TMOA. So I can take this gram, put it over here. So I said I have 0.54 gram of TMOA here. So what is the number of moles I have here? So number of moles is really the key learning for this little YouTube. So if I divide 0.54 by 75.1, that's the number of moles I have for TMOA. That, if I use my little Excel sheet here, is 0.0072 moles. Now, how would I do that? I know that number of moles, this is a very important formula to remember. Number of moles is always gram of the substance over molecular weight. And that's what I did. I said 0.54 divided by this is 0.0072. Now, in chemistry, we always say if something goes 100% to a product, 100% product, the number of moles are the same. So the number of moles for trimethylamine is also 0.0072, and everything goes well and trimethylamine react with the acetic acid. I also need 0.0072 moles of acetic acid. So these are the moles now. We have a moles, moles, moles. And we assume they're all the same. So now we need to know what the gram is here for trimethylamine and gram for the acetic acid. If you're interested in gram of acetic acid. Remember we divided gram by molecular weight to get the number of moles. So if you have the number of moles, gram is going to be a multiplication of moles by molecular weight. So if I do that, so I would need but 0.43 grams of, or I produce 0.543 grams of trimethylamine, and I need also 0.43 grams of acetic acid. The reason here these two numbers got same is because molecular weight for acetic acid and trimethylamine are very close to each other. So we need 0.43 grams of acetic acid. So how much is that in vinegar? So let's take a look at that. So we're going to look at the 0.43 grams of acetic acid and see how much vinegar. How do we spell vinegar? I always forget. How much vinegar we need. We know that vinegar is basically 6% acetic acid in water. So let's do the calculation. Let's do the calculation for that. So I'm going to put a new paper here. So I'm going to put a new paper here. I always like to put page number here. So I put a page number 2 for my moles calculation and weight percent calculation. Okay, so we're back to our vinegar, huh? So we need 0.43 grams of acetic acid. Let's say if the vinegar that we're using, typical vinegar, let's draw my little bottles here, not a good draw. So that's my vinegar bottle. We know typically 100 grams of the vinegar, how do you spell that? Vinegar has 6 grams of acetic acid. That's a typical ratio that we have for the vinegar. It's not 100% acetic acid, it's 6%. So we don't need really 6 grams acetic acid, we need 0.43. So again, these are conversion factors that we're going to work on. I always like using ratios. I found that a lot easier to understand the factors, but you might be comfortable with using factors. That's fine. So what I usually do, I say, okay, tell myself 100 grams of the solution of vinegar in my little bottles has 6 grams acetic acid, right? Again, this is my factors, but it's the same thing. But I don't need 6 grams of acetic acid. I need nearly 0.43 grams of acetic acid. And I always put right here, so acetic acid on top of each other. Vinegar solution here. I don't know this X is, right? But now I have a little ratio. I can say that the X, basically the gram of vinegar that I need is basically, remember 6 times X is equal 100 times 0.43. So my X would be multiplication of these two, 0.43 times 100 divided by 6. So this is the factor that the textbook teaches. So my X is basically 7.244 grams of 106. Yeah, that's right. Gram of this vinegar solution. Or I can do opposite. I can also look at the uh, recipe, and the recipe, how much acetic acid the recipe provided. So let's take a look at that. If I look at the recipe that my wife used, it said that let's use 1/4 cup of the vinegar, right? Quarter of vinegar. So I actually went and weighed the quarter cup of vinegar we use, and that was 64 grams of the solution we use. Now, if I take that 64 grams of the solution and multiply by, again, remember 6% of it is acetic acid. So if I multiply by 6 over 100, so that came about 3.84 grams. So we used, instead of using 0.43 grams of acetic acid, we used a lot more. We use a lot more, which actually is a flavor. So we use more of it, and that gives flavor to the fish during the cooking. Vinegar we use in salad dressing and other things for the taste. So that's my little calculation. Now, what if you use lemon juice instead of acetic acid? We have used lemon juice in the past on the fish, so maybe I'll talk about that later on in a different uh, YouTube. And so this was my little calculation. Take a look at it. And we are going to do some of these in the class. The key, again, back to my little table here, is the moles. So moles of TMOA, moles of trimethylamine, and moles of acetic acid. I assume they're all the same because of the 100% conversion. Use different molecular weight and different grams, but the moles are all the same. Thank you.